Good afternoon, everyone. Thank you for coming to my talk titled Real-Time Sentiment Analysis Application Using Hadoop and HBase in the Cloud. My name is Jagane Sundar. I'm co-founder of AltoScale. A little bit about myself. I have extensive knowledge of Hadoop, cloud compute, and virtualization. I'm co-founder of AltoScale. We have a couple of pieces of software we've developed. One is the Hadoop Workbench, which takes Hadoop and HBase and turns it into a service that runs in the public cloud or in VMware environments in your private cloud. Our partner VertiCloud makes this available on the public cloud, and we work with VMware to make it available to enterprises from within their data center. This is by far the simplest and most comprehensive way to run, develop, prototype, and take to production HBase and Hadoop applications. This application, the real-time sentiment analysis application, was developed on the AltoScale Workbench. I've worked at Yahoo for Eric 14, CTO of Hortonworks, in the Hadoop management and performance areas. I'm primarily a systems and storage guy. I've written TCP stacks and NFS clients. I wrote an NFS client for Java OS in Java back in the day for Sun Microsystems, and I wrote a TCP stack for packet design with Van Jacobson. And I wrote a piece of open source software called Live Backup for KVM, which enables you to back up virtual machines without having to shut them down. So what's my motivation for writing this application? In other words, why am I, a systems guy, sitting around writing an application? I felt that I needed to write a big data real-time application, a cool one, in order to understand end-to-end how a big data system might work and be useful. All too often, our system guys sit in one corner of the world and look at it from that perspective. We really don't understand how the features we're trying to build or how the features we're trying to get into the system end up looking like and feeling to the end users. Are they even useful? So this is my effort at trying to understand what it means to the end user. So enough about myself. What's in it for you folks? What I'm hoping to do is to show you how easy it is to build a real-time big data application using a variety of open source tools that are fairly mature, easy to use, and almost all freely available. We love HBase and we love Hadoop. My co-founder Constantine spoke about his project earlier on, a file system, a distributed file system, next generation HDFS, if you will, called Giraffa, that uses HBase as its metadata store. So obviously we love HBase. We think that it's a very cool piece of technology, and I'm going to show you how you can use this to build a very nice application. So let's talk about sentiment analysis for a bit. There are a number of signals you can get to do your sentiment analysis. The most easily accessible one is Twitter public status updates. There are other sources such as blog entries, RSS feeds, status updates on Facebook, Google Trends. Each of those is harder and harder to get a hold of. Facebook, for example, is really a walled garden. You can't get access to that information. Google has a wealth of information, but it's not easy to access. Google Trends, for example, will tell you what people are searching about most in any specific time period. But that's not available through an API, so for the public internet or people like us at large, you can't get a hold of that information to build some sentiment analysis time series, if you will. So I picked Twitter public status updates as the only source of this sentiment analysis application. And I would like to speak out a word of positive note for Twitter, because a lot of their stuff is available using APIs. You can just log in, no big authentication, or you don't need to go through a vetting process to get a hold of their tweets, for example. That's wonderful, and it's great in the sense of the open internet. would love to encourage them. So sentiment analysis itself is, when I started thinking about it, I was wondering what would be useful to customers. And my friend Colin, who's sitting in the front row, helped set up some conversations with investment professionals and others who might be end users of this application. We went through a lot of conversations, and the conclusion I came to was what people might find most interesting is a history of sentiment, if you will, of specific keywords. In an ideal world, every keyword in the world that a person might be interested in is something you should have a history of sentiment on. But that's not very easy to do. One, I don't have all the tweets that Twitter gets. And two, there are other sources that are just too big to hold and store and process. So I'd like to divide this problem into two types, where you know the keywords a priori. In that case, it's an easier problem. You can make do with a smaller amount of tweets that I can grab, and that's good enough to pour into HBase and make a useful application out of. An open-ended sentiment analysis application is harder to do, and in many cases, the data is not available in the public internet, so that's an exercise for the reader, if you will. So this is a block diagram that kind of shows you what the application looks like. We use Hadoop and HBase, obviously, as I mentioned before. And the box in the middle is what our workbench provides. It's essentially a way to orchestrate Hadoop and HBase so you can bring it up. Now, all of the stuff we are using is standard open source Hadoop. It's Hadoop 1.0 and HBase 92.1. And the bits are exactly what you can download from Apache's website. Our software just orchestrates it and makes it really easy for you to use. We use the Twitter streaming APIs filtered on specific keywords. I have a slide in the next page showing you what types of APIs Twitter has and what was most appropriate for this application. And once we get the tweets in, we do some sentiment analysis of those. I use specific open source libraries that I'll mention also. And we write new rows into HBase for every minute. You could update this more frequently should you want to do so, once every 15 seconds or 30 seconds or so. But a minute gave me a good granularity. And how do you get this data out and present it to the user? That's the second half of the problem. You're constantly getting these tweets and you're ingesting it, you're doing some processing, pouring it into HBase, but what does it look like in front of the user? The technologies I chose to do this were JavaScript. It's a simple JavaScript application, lives in a HTML5 browser, and it uses a REST call to talk to HBase using HBase's REST gateway that's provided as part of the HBase distribution. There are some problems there, which I'll talk about in a little bit more depth later on, but these are the sorts of problems that the folks who build some of these core infrastructure components don't really pay attention to or don't appreciate the full value of. At the end of the day, to build an application, you do need to solve the problem of getting the data out. And I'll show you what I use to do that. So if you look at Twitter's APIs, I'm by no means an expert on Twitter, and there are probably others on this very floor who have a great deal more expertise. But from somebody who studied the API for a few hours, I can tell you this is what it looks like. There are the REST APIs where you make request responses and you get specific tweets. This is for a client. If you were to write an iPhone client for Twitter for a single user, that's the API you would use. The streaming APIs use persistent HTTP connections, and you get a stream of tweets of different flavors. There are user streams where you sign on as a single user and get that single user's tweets. You could use that for building an application. There are site streams which stream the tweets of multiple users, and the site is responsible for holding true to some of Twitter's privacy policies. And the last one is public streams, which are a sample of all public updates. 1% of all the public status updates or tweets are available to anyone. You can log in with your username using a streaming API call to to their service and get 1% of the tweets just like that. I find that among the most open approaches to computing today, and I wish that other vendors like Facebook and Google would be more open about their data. It makes for a much more interesting world, makes for a much more interesting internet. In the public streams, you can either sample it 1%, which I just talked about, or you can get 10% off feeds, which is a Firehose feed, and that's available for purchase. There are business negotiations that need to be done, and that's fine. Twitter is a business, they need to make money. Then there's Filter API, which is interesting. You can submit up to 40 keywords and some number of specific Twitter users if you want to follow, and the streams or the public status updates of those keywords with those keywords in them will be sent to you. If it exceeds 1% of the total tweets, then you might get filtered or you get a notification saying you're being rate limited. I actually have not run into that problem at all because I chose pretty popular phrases like Obama and Romney, and even with those popular, this being an election year, you would think that's one of the more popular tweets, but it never exceeded 1%. So I don't think exceeding the 1% limit is going to be a problem for you. So what does the database look like? This is something that I struggled with for a bit. When I first sent this proposal out, I was considering writing it out to HBase and then connecting it to R and using some R scripts to graph it. That was one option I had. I was thinking maybe I should just port it straight into HDFS and do some Hive-based batch processing and produce some graphs of some kind once every 5 minutes or so and use those graphs for display. All of those were not really real-time and not really interesting. The problem I really saw was I wanted this to be an interactive thing. I wanted people to be able to click on a specific portion of the graph and zoom in if they wanted to, click on a specific portion and see the tweets that resulted in that number. Let's say there were 5 people who tweeted positive about Obama during that particular time that he's looking at. Perhaps we should look at the tweets. Or if you're following sentiment of a brand name, Samsung, for example, there's a lot of negative tweets. You want to look at what particular thing about Samsung are people upset about. Is it their dishwasher or is it their phone or whatnot? You would want to drill down. That's a real-time application. One where you run Hive queries and produce a bunch of graphs and give people the ability to go look at pre-canned graphs. Seems very non-real-time batch processing, reminds me of COBOL, if you will. Didn't want to do that. So I ended up with looking at TSDB, which is time series database. That's a project that's built on top of HBase for storing logs. Not logs, it's more like monitoring information from servers and routers and things like that. So TSDB is used, I don't know if it's stumbled upon or there's several companies using it, but they have a very scalable system where they can pour statistics from multiple thousands of devices in their network into HBase, and they have the ability to scroll back and forth, look at problem, go back and analyze previous instances where such things were present. It's a very interesting application. At the end of the day, I did not use TSDB though. I chose the architecture, or I did very similar things to what they do, but I built it on top of raw HBase. This is not that much of a problem because at the end of the day, this whole project was a weekend project for me. It took no more than a few hundred lines of code, some amount of Mickey Mouse stuff with JavaScript, but that you can do for endless hours. I mean, once you start adjusting fonts and sizes, you could spend days without any real productive work. But anyway, this gentleman, Benoit Sigur's slides from HBaseCon 2012 are really useful in this context. It's a good read. So here's what the table looks like. After all this mulling, I decided to put the table in this format. The row key is the keyword that we're looking for, and the date, because I want the ability to scroll back and forth in date. So if you're looking for Obama presidential candidate or Romney presidential candidate or Dave Barry presidential candidate, you might see row keys like that. I store the number of neutral tweets, the number of positive tweets, the number of negative tweets, and I actually store specific tweets. Initially, I thought I would store all the tweets. I haven't quite decided. This is still very much a work in progress, and I think storing maybe the tweets of the top 10 influential Twitter users or tweeters might make most sense, because there is a certain level of information that those tweets contain, but too much of it is not of much value anyway. So this is what the table looks like. What does the application itself look like? This is just a capture of our web page. It's JavaScript, as you can see, and it comes up with a keyword. This is not fully honest. In other words, there are only specific keywords that we've done this HBase indexing and row created, and the ability to go back in time and look at sentiment of those keywords. Ideally, what I would like to do is take a large subset of keywords that this person is interested in. Let's say he's a stockbroker who trades a specific industry segment. All the keywords related to his industry segment may be 40 or 4,000 or some number of those. We will have the ability to do look back in time at sentiment of all those keywords. Or if you're following a specific sports personality or a sports team or related things or game, baseball, whatever, those would fit into that. In a really large scale system, you could hold tens of thousands of keywords, I suppose. But what I'm looking at is much smaller. What does the application look like? Now, I'm going to show you a demonstration of this application running at the end of this, and I'll show you all of our software working on the workbench. But this is a simple graph that it produces. It's a list of positive tweets about keyword Obama for the date 10 June to 11th June. You have the ability to go back and forth in that particular graph. I really don't have that much more functionality built in, but what would be good to add is the ability to mouse over some of these spikes in the graph and see what people were tweeting about. And there are spikes in the graphs. There's a great deal of information in these graphs that become visually very clear if you start playing with some of these applications. Some mentions I need to make. We are, standing on the shoulders of giants. A lot of the projects that I use are thousands, maybe even hundreds of thousands of lines of code, and many talented individuals working on it. The software that I ended up using, Hadoop and HBase, of course, things that I'm very fond of. The Twitter 4J library in Java is a really nice piece of software. It worked really well for getting a hold of tweets. The sentiment analysis part of it, I looked at a lot of the code out there. There seems to be a few different schools of thought. I'm by no means expert in that, but NLTK is a natural language toolkit in Python that seems to be very popular. The one I chose to use is the Weka library published by a university in Australia, and I chose it for actually something really not relevant or should matter in this. It's written in Java, so the rest of my software is in Java. It just plugged in really easily. But if you're building a serious application, taking it to production, you should investigate that a little bit more and pick a library that's best suited for your purpose. Tomcat is a server. I mentioned before I had to do some fiddling to get the JavaScript out to the client browser so that the browser can come back in and make REST queries and get to talk to the HBase. I needed to do a proxy with Tomcat for that purpose, and I'll tell you why in just a bit. jQuery is the JavaScript library that I used for making the REST call back into the HBase. That worked really well. It was pretty obvious, and I didn't have a great deal of difficulty there. Dojo was the library, the JavaScript library that I used for graphing it. The pretty graph that you saw is actually very easy to do from this Dojo library. A couple of slides with code in them. I want to show you how simple this is really. This really is. And this is the status listener, which is a Twitter 4J interface that gets called back every time there is a status update. and the status object is supplied by the Twitter4j library. This weighted classify is the classification into positive, negative, and neutral tweets. There's some science there, and it's not a perfect science. There may be experts in natural language processing out there who know better about how this is done, but I think there's room for improvement in that part of the open source world. So I get a polarity out of this, and I call a function update keyword trackers, because I want to write the sentiment out once every minute. And during the minute, we keep getting tweets, we keep processing it, and I bump up the count in this keyword trackers that says, for this keyword, this many positive, this many negative, and this many neutral tweets, and here's a sample of positive, negative, and neutral tweets. The next slide is a little bit harder to read, but this has the code that actually writes into HBase. Now, so there's this Bible of HBase, the authoritative HBase book by Lars, and it's an excellent book. It gives you great insight into how HBase works and how HBase is architected and a lot of that. But there's actually not a whole lot in that book about how to write clients to talk to HBase, to write to HBase, to read from HBase, and I think that's an artifact of the maturity of some of these software pieces. I think we're all focused on developing the core components and not so much on helping application developers use the core components. That said, here's what it took for me to write this row out into the HBase database. It's actually very simple and intuitive. If you look at it, I make the row key, which consists of the keyword and the date in year, month, day, and time, so that I can scan it later on. One of the key features of HBase that I use here is partial row scans, where you can scan for a specific subset of the row. And that gives me the ability to say, give me all the tweets or give me all the rows about Obama starting from 24 hours ago to now. And that helps you make the data transfer from HBase to the client to be much more limited. So table.put stuffs this into the database. So let's talk about the client for a minute. There are several options for writing clients that talk to HBase and producing something that you put in front of a user. One obvious thing to do would be to write a Java client that uses the HBase libraries, runs in the cluster. It could be in some service node, which is what I do, or it could be as part of the same node where the HBase master is running. And you link to these Java classes. They make calls directly to HBase, get the data. Then you're left with the responsibility of converting this to some format that you can display in. Maybe you'd use an RPC to get the code over to an iPad client or some other such mechanism. There's another technology called Thrift, which is an RPC mechanism that it's an Apache project that's natively supported by HBase. You have to start up the Thrift server, and you can make Thrift calls to that. Once you've got the Thrift gateway fired up, you can write a Thrift client that's also in any language. It could be Java or C, C++. The Thrift system is actually language neutral. And that client becomes embedded into your client. That piece of software gets embedded into your client. Again, this is not what I chose to do. I chose to use the simplest way to get data out, which is to use a REST API. You need to fire up the REST gateway, which is a piece of software that's included in the HBase distribution but not started by default. In our orchestration software, we have the notion of service nodes, and in one of our service nodes, we fire up the REST gateway, and that is the piece of software that I'm going to talk to. Now, several times in my talk, I've alluded to this problem of how can I get the JavaScript to go back and make a REST call into this REST gateway. So the problem really, if you dig deep in, the problem really turns out to be because of security limitations and cross-scripting hijack attacks, the browsers are all uniformly not allowing JavaScript to make REST calls to any server other than the one that it was loaded from. The problem is the REST gateway that's included in HBase does not have the capability to serve up JavaScript. So you need to put some sort of a gateway in front, which will proxy in front, which will serve up the JavaScript, but when the JavaScript loads into the browser and calls REST calls back, it needs to be able to proxy those calls to the thrift gateway that HBase gets. So that's where Tomcat stepped in. At the end of the day, you can do scans on table, partial row scans, you can get all the data. It turns out to be very efficient because the browsers negotiate HTTP compression, so the data transfer is actually quite efficient, and I was surprised with how much data you can transfer in this method. You really don't seem to need a binary protocol or RPC of any kind. This works just as well. So the details of this are the REST server runs on port 8081 in this service node, and the REST server has the capability to scan tables. JavaScript web page is the client. I talked about the security problems and why I needed to do the proxying. So how can we improve this? We would like to make this more elastic. Operating a HBase cluster in the cloud is expensive. It costs money by the hour. What I would like to do is to say during the daytime when the sentiment analysis application is really necessary, we'll run the HBase cluster, we'll run this application. At nighttime, we'll continue to ingest the data from Twitter, but we'll write it into sequence files in S3 or some other low-cost storage mechanism. 1 hour before business starts or 1 hour before you need the HBase application to be running, you would fire up a MapReduce job, take all the sequence files and process them, pour them into HBase, fire up HBase. At this point, HBase can do both, ingest data and it can serve up web pages, but you've effectively cut the cost of operating this application to less than half what it would otherwise be. Now, this is the sort of approach that not a lot of attention is paid to in either fully private cloud, you own your own cluster, you don't care about resources type of approaches, or in the public cloud if the cost is not too high. I think that it matters. It actually helps to make this system a lot more cost effective. A couple of notes about big data applications in the cloud. This is some of the things that we've learned. They're fairly obvious, but it is helpful to state them explicitly. There are some applications for which the cloud is eminently suitable for big data apps. If you are doing a lot of processing of data that's in the cloud or in the intranet or generated in the cloud, obviously a great place to run it is in Amazon or VertiCloud or some other such service provider. If you have the data inside your network, maybe you shouldn't be running your HBase out in the cloud. A hybrid approach may be to say, take all the public data, do some analysis or intermediate processing on it, and then pour it into a HBase running in your private cloud. So some of the applications that are suitable for use inside your network, Splunk-like things, you're processing logs, you're storing device logs, those sorts of things generated inside the private network work great in your own network. So I'd like to do a small demo of our workbench. Let me show you what our workbench looks like. So this is the workbench desktop. One of the aspects of our workbench is that we create this HBase cluster in the cloud for you, and we also have what we call the desktop VM, which is a virtual machine with a bunch of GUI tools that you use for big data development. Eclipse is what is running right now. We have HBase here. I can, for example, bring up the HBase shell fully connected to my HBase and do a scan table on it. There is the name node. Let me do a status on it. It's going to show me. This is a microcluster. I have just 3 slave nodes. I can go into the Uzi web page or the name node web page, for example, and here you can see that we have 94% of the distributed file system available. So there is a fully integrated desktop virtual machine available for you. Let me do a quick scan of the tweets table to show you what it looks like. So that's roughly what the application looks like. The next part of my demo, let me show you the application itself. Once I hit reload, so this is as simple as it gets, and if I hit Obama, it takes a couple of seconds to get the data over. And you can see that there were about 10 positive tweets about Obama every minute or so. Each of these lines is a minute's worth of information. Let me type in Romney and see what that returns. So you can see immediately that the number of tweets about Romney is actually about half where Obama is, which was actually surprising to me. It looks like there are more Democrats who are Twitter users than Republicans. So that brings me to the end of my talk. So if you have any questions, I'll be happy to answer them. Or if you want to use our workbench, if folks we can bring online to help you do that. Yes.
So yeah, so the product looks good. Your web page looks quite snappy. But I was just wondering, what kind of average latency do you see querying the data out of HBase? You know, what sort of average latency and
so I've actually been pleasantly surprised with the latency. You saw it takes about a second to second and a half to get the data out. This is a small cluster. It's a 3-node cluster, and it's probably got anywhere from 20,000 to 30,000 rows that's stored in it. But latency has not been a problem for me at all. It's very responsive as far as I can see. So we don't like to push HBase too much. I don't like to get HBase beyond 50% capacity, and if it's running high on CPU, then we want a bigger cluster. But HBase has been very good so long as you don't push it to its limits.
You mentioned something about drilling down the application, the real-time application. So I'm wondering, do you have anything in your demo to show or to shed some light on that?
I would love to do that, but I don't have that functional yet. I will admit I'm more of a Java programmer than a JavaScript programmer. So I've got all the stuff in HBase, but I couldn't come up with a JavaScript to do the drill down in time for this presentation. I'm sorry.
No
it's not functional at this point.
Thank you.
Have you, sorry, one more question. Have you considered looking at some of this libraries like Storm, since you did everything within HBase and you're kind of trying to do real-time sentiment analysis? So what are your opinions about that versus just using HBase?
So I looked at Storm, and I didn't look at it in enough depth to really give you an answer whether that's better or HBase is better. But we started off building the workbench with HBase built in, and we mastered the job of running HBase as a service. Once we had done that, it seemed like it was just there waiting for us to use it. And that's why we ended up using HBase and not Storm or not even TSDB for that matter. I think TSDB is also interesting in this context.
All right, thanks.
Thank you. All right. Thank you, folks.